Hi there, everyone. Let me repeat myself regularly on a near daily basis and say just how lovely it is to see all of you arrived, ready to learn new knowledge and to show up for your learning in a way that just makes it worth getting out of bed every morning. So thank you very much for your continued efforts in that way. Today we're looking at periodic functions, other things that repeat. We repeat this behavior on a daily basis during the week of arriving and then moving through the school and all of that. And that's just such a delight. So today we're going to start with a hands-on exercise. What I'm going to have all of us do to start the lesson is start by being aware of our breathing. Just notice it come in. Notice it go out. You don't need to breathe in a special way, just be aware of it. And then just for a reference point, take as deep a breath in as you're able to, like fill from the top of your head to the bottom of your butt. And feel what it feels like to be at 100% breath. Are you doing it? Oh, I don't see people doing it. Try it. Breathe in as far as you can. And then try to breathe out as extremely as you can. Like go down to as if you can squeeze the breath out all the way down to 0. Just feel where that is. People get a sense for where the 0 is on your breath and where the 100 is on your breath. Like a 0% breath is like down here, and it's like we're rarely down here. You don't spend much time down here. But then the 100%, we're also not up here very much either. So just be aware that's my 100, my 0, and just kind of have a feeling for that. For this exercise, what we're going to do is just chart where you are along the in your breath, where you are between 0 and 100 throughout a minute. And you're just going to graph that as we go. Okay, and I'm going to graph it too. I'm interested to see how this goes. I'm going to get my blue pen out and turn our timer on. Are you ready? Maybe we'll all start kind of at the bottom, natural bottom point of our breath. So breathe out, and here we go. Oh, sorry. There we are at 50 seconds, so that's 10 seconds in. Coming towards, there I'm at 20 seconds here. Okay. All right. Did you get a graph? So as we went through those seconds, did you get a sense for where you were in your breathing? I kind of feel like I go between about 20% of my breath is like my natural exhale. I'm not all the way down at 0. My natural inhale up there about 70% or so. And there, I took about 4 breaths in that minute. Where are you at? What does your graph look like? Oh, faster breathing rate there. Cool. All right. This is an example of periodic behavior. And you can, you can watch this in your own body as something that repeats on a regular basis. So the next thing that we're going to do is we want to have some vocabulary that we're going to be using to talk about this type of periodic behavior. So you're going to be on the hunt for definitions for these terms while I go through the following comic. I made this comic during distance learning. And if you've ever like written an essay for one class and then handed it in for another class and gone, yeah, and you feel like you feel kind of like good, like a meme. And yeah, this is how I feel today. So welcome to Learning Today, everyone. And I thought that this like blank white void was a little boring. So if we can give it some life with some periodic functions, that would be great. Heartbeat, another example of a periodic function. Let's keep going. So we're going to learn about some really, I think this is seriously cool stuff in this unit this week and next week. So many things in our world are repeating periodically. Weather, the day goes to night, goes to the day, goes to the night. If you go out by the beach, you'll notice there's waves hitting the shore. They're periodic. Sound waves in the air are also periodic, and that's really cool. Anyone that's interested in a career in music and also how can I blend my mathematical skills with that, you're going to find a lot of interest in this unit here. And even the heart in your chest, these are all periodic behaviors. So we're going to, you want to get these definitions coming up. Periodic functions, how do we define those? They're functions that regularly repeat over a specific interval. Specifically, the y values repeat over a specific number of x values. So we should see the same pattern over and over again. If I look at my breathing pattern, it was a little bit irregular, but you can see a definite periodic nature to that weird squiggly graph. Okay. In the case of your heartbeat, on the other hand, the x values represent time, and the y represents your blood pressure. As your heart squeezes, your blood pressure goes up, blood is pumping through the body. As your heart relaxes, it goes down, and your heart has that distinctive rhythm to it as well, which is periodic. When your heart, if you're alive, that's a pattern that's repeating periodically. So here's a pretty funky periodic function. As you can see, it's been graphed in Desmos, and there I am there, and you can see it goes up sharply, does a little squiggle, comes back down. Let's talk about it and some of the other ways that we can describe its behavior. If we look at it, you see if we start here at 0, it goes up, does a squiggle, comes down, does a squiggle, goes up again. And then every 2 units, it seems to be repeating the y values along the x-axis. Back here between 0 and -2, for example, we see the same pattern. And it continues on after 2. So 1 cycle is 2 units long in this case. A cycle of a periodic function is the 1 repetition of its pattern. So your heartbeat, 1 cycle would be lub-dub. Your breathing, 1 cycle would be inhale, exhale. For the position of the sun in the sky, 1 cycle would be daytime, nighttime. And nowadays, it's more like daytime, nighttime. Nighttime is very long these days, and daytime is very short. Okay. So when you see one pattern repeat on the graph, that's 1 cycle length. This case, a cycle length is 2 units long. So between my hand and my hand over here, you can see 1 cycle of the graph. Huh? I'm a little surprised to see myself. What's going on? And so I ask, who are you? And I say, oh, don't worry, I'm you. Everyone talks to themselves during distance learning. All right, it was a different time, everyone. Everyone went a little crazy, okay? Myself included. So anyway, the length of 1 cycle is called the period of a graph. So here you can see the period. It's in purple between my finger and my finger there. So if you find the length of 1 cycle, that would be the period. Okay? And the period of your heartbeat is the amount of time it takes for your heart to beat once, and then it rests a tiny bit of time before the next heartbeat starts. That little, call it a flat line, maybe not the right idea. The little rest in between a heartbeat would be part of the period. Again, you can see 1 full cycle here from up, down, up, and then a little bit of boop until the up, down, up starts again. Between my fingers there, you see 1 cycle. And so the length of that in terms of x values is the period. Yeah, and I know we're all distance learning, but I should be a little professional and kind of put on some pants there. So I'm a little shocked by that. Okay, so thanks. Now that you're wearing a belt, how that we talk about the horizontal axis. And so I say, well, that's my pleasure. So the horizontal axis of a function, a periodic function, is kind of the midline between the maximum y value of the function and the minimum y value of the function. You're going to see the horizontal axis there. To find the equation of the horizontal axis, all you're going to do is find the average between the maximum and the minimum, and that's the horizontal axis. So here, in this case, the function has a maximum of 2 up there, and the minimum is down there at negative 2. So the average is 0. Therefore, the horizontal axis is y equals 0. Then, notice that both I and the function have been translated upwards. Now the maximum is up there at 6, the minimum is down there at 2, and the average of those, 6 plus 2 divided by 2, is 4. So the equation of the axis now, y equals 4. All right, so that's kind of just the midline, that line that runs through the middle of your function. Then, another key definition, amplitude. If this was a sine wave, amplitude would be related to volume. How loud is it? Okay. Here, let's talk about it. The amplitude is just the distance between the maximum and the horizontal axis. Or it's the distance between the minimum and the horizontal axis, since both the maximum and the minimum are the same distance from the horizontal axis. If you can imagine like an oscilloscope measuring a sound wave or something, and it starts and it's barely moving. And then as the volume increases, the air pressure in the air both goes down and up in a rhythmic succession. So as you increase the volume, it's departing from the midline. However much it departs from the midline is the volume. So amplitude is not the distance from the top to the bottom, it's half of that. It's from the top to the midline. Okay, so in this case, if I chained together a bunch of myself like paper dolls, our belts would be the horizontal axis. One cycle would be one example of me, one paper doll me, and the span of our arms, the length of my arm span would be the period. One cycle is the period. And the distance between our head and our belt, or my feet and my belt, assuming my belt bisects my body, would be the amplitude. And there's one more big definition that we're going to look at, but we'll look at that later, and that's phase shift. And that's basically where did we put the y-axis? Where was our initial position? So we don't need to worry about that right now. So let's go back to this example here and talk about what those definitions represent in the example above. First of all, is this an example of a periodic function? Kind of.
Sure.
Yeah, sure. Yeah. And why? What's the definition of a periodic function? Yeah, okay. If you play the sound in Desmos, it goes wee-hoo, wee-hoo, wee-hoo in a periodic and predictable way. That's a good definition. Well, no, it's not a good definition, but it's a good thing to remember. Yeah, a periodic function is a function that repeats its y values over a specific number of x values. So we see here, I am going between 70% of a full inhale and 20% of a full exhale regularly over a certain number of x values there. Seems to be about every 20 seconds I'm taking a breath. So let's see. What's the amplitude of this function? Well, the midline of my function, and you can analyze your function because you created a graph yourself at your own desks. What you can do is analyze your function and say mine, the maximum is 70%, the minimum is 20%. So if I add those together, I get 90%. If I divide that by 2, that's 45%. This is the equation to find the midline. So here, the axis, the horizontal axis or the midline, my equation is going to be max plus min divided by 2 is going to be the equation that gives me the axis. In this case, it represents like the middle point between inhale and exhale. And we can graph it here. 45% is the middle point, the average between 70 and 20%. So that's about right there. And I can graph the midline along like that. And then you'll see the maximum value is about the same distance from the midline as the minimum value. Here's the maximum. Here's the minimum. You can label these things on your graph as well. And then the amplitude, what is that? Well, that's the distance between the max and the axis. So in this case, it's between 45 and 70. So that's, what is that, 25? Yes, 25. So it's half the difference between these two. 70% minus 20% is 50%. That's the distance between the maximum and the minimum. Half of that is the amplitude. So about 25% is what I'm oscillating through. So what does it represent above? How deeply am I inhaling? Right now, you're relatively at rest. You're all sitting. You're absorbing new information. Your mind is working very hard, but your body is not. I am standing, energetic, and a lot older. So this takes more energy for me than it does for you. So maybe that's why I might be breathing a little deeper than you are right now. You can imagine if I had to run up the stairs to get to this lesson and I start and I'm doing this, that the amplitude of my breathing would increase. Okay. Now, what's a cycle? One cycle would be, in this case, one full breath. One full exhale and inhale. That would be one cycle. And what's the period? Well, the period is the length of one cycle. So here I have the period of one breath. And I wasn't trying to time this to make it 20 seconds. You'll see it's actually a little shorter than 20 seconds. This next one, I would probably take the average of these 3 breaths here, because I had like 3.5 breaths over 60 seconds. So let's calculate that. What's my period length? I had 60 seconds, and I divide that by 3.5 breaths. So I'm taking a breath about every 17 seconds. That's for me. You find the period of your breathing using your function that you created. So for me, it's about 17 seconds equals 1 breath. That's 1 period of my breathing for me. And then the maximum and minimum, what do they mean in here? Full inhale and full exhale. Cool. So what are we going to do next? Next thing that you're going to do is we will take until, well, about 3 or 4 minutes, so about until half past. And in your table groups, I want you to create a list of cool periodic phenomenon in your world, something that you might have a mathematical interest in or not. Periodic phenomenon might be Taylor Swift ticket sales. She releases an album relatively periodically. It's probably what is like once every 6 years or something. And then people go crazy and buy her tickets. And she goes on tour. And then probably the ticket sales drift off a little bit until she releases a new album. This could be one periodic behavior in our world. Or you choose it. It could be, well, I want to be a big wave surfer in Hawaii. I'm very interested in the periodic behavior of them waves. So create a list of those and find the coolest ones that you want to share with the group. At half past, you're going to share those back with everyone. For Team Learn at Home, thanks for showing up for your learning. I would encourage you to try these problems on the back page, Team Learn at Home, and also try these Check Your Understanding problems, which we will work on shortly. Bye for now, everyone.